Now, the second historical GIS study I want to talk about is a 1960s environmental planning study by this fellow here who's called Ian McHarg. Now, as with the John Snow example, Ian McHarg developed a spatial technique, and GIS is just a tool that made the technique far more efficient. Now, because of the technique he developed, McHarg is regarded by a whole bunch of people as being the father of landscape architecture. He's also regarded by a whole bunch of other people as being the father of GIS, and I think the reality is that GIS has a number of parents. As for the John Snow example, where I asked you to look out for GIS parallels, like the fact that he geocoded the subjects for his study, like that he did field validation to address data quality issues, that he paid a lot of attention to map quality, and also that he did network analysis, there's a couple of things I want you to look out for in this study. And the first is spatial database creation. And by that, I mean the attention that McHarg paid to bringing a bunch of maps together at the same scale. Now, the second thing I want you to look out for is map overlay. Now, this is a really, really important concept to understand, but it is only possible once you've got this first bit here, the spatial database, once you've got that in place. If you understand map overlay, then I reckon you are a long way along the path to understanding GIS. Now, map overlay is the idea that you can overlay maps onto each other and see different bits of information about the same place. It's a really, really important concept, and it's used day to day in so many organisations these days. And at its simplest, I've seen it at front desk in local government, where somebody might overlay property outlines onto an air photo. At its most complex, researchers might relate multiple maps to each other using weighting techniques or statistical techniques. So it can be as simple or as complex as you want, but the fact is that it's still map overlay, and it has its origins in this manual technique that I'm about to show you. Now, when McHarg developed this technique that I'm about to show you, geographers poo-pooed the technique as being nothing new, because of course, as geographers, these old-fashioned dudes, they'd been overlaying maps forever, right? And I have to point out, I'm a geographer too, so I think I can say this sort of stuff. But the thing that McHarg did that was different to what they were doing was he was the first to consistently make the effort to pull a bunch of maps together at the same scale and in the same place so that they could be overlaid onto each other. And the other thing that he did that others hadn't done before is that he took his methodology to the community. And this meant that planning became more open, it became more reproducible, and it became more communicative. So let's talk about this map overlay project. There was a proposal to join two sections of roadway, both drawn here in blue, in Richmond in New York. And the route that the planners and the engineers proposed created a fair bit of community uproar, because the intended route went through parks, it went through recreational areas, and it went through forests. Now, McHarg was brought in to try and resolve the issue, and what he did was he ended up creating a series of maps that dealt with the concerns of both the community and the engineers and the planners. And here's the maps that he came up with. So what are the things engineers are interested in? Well, basically they're interested in where's the best place to build a road, so that it's not going to fall apart. Things like a road's going to be cheaper to build if it's on shallow slopes. It's going to be a better construction if it's got good drainage and the soils are good. So what sort of things do the community value. They're interested in being able to recreate in the forests. They don't want their old homesteads bulldozed. They don't want to lose institutions like hospitals or schools. They want all their recreational values. They don't want their houses demolished. They enjoy the scenery. So for each of these values, Ian McHarg produced a map. But what he did that was really innovative was that he produced the maps at the same scale so that they could be overlaid. Now, we've talked about that. But the other thing that was really innovative was that he shaded each of the maps in 3 tones. The darkest tones represented those areas that were the least suitable for the roadway. Grey shades were moderately suitable, and transparent areas were most suitable. So in other words, if we were to look at a slope map, areas with really, really steep slopes would be dark, hilly areas might be grey, and flat areas might be transparent. The idea is that when all the maps are overlaid on top of each other, the darkest areas would indicate those areas least suitable for the roadway in both engineering and community terms, and those areas that were transparent would indicate those areas that were most suitable in engineering terms and also create the least conflict. So what you're about to see is each of these maps here overlaid on top of each other. Now what I've done is I've scanned each of the images out of the book, and then I've geo-referenced them and overlaid them in a GIS. On a light table, the dark areas overlaid would be far more obvious than what they are here. But sometimes you just need to make the best of the information that you have at hand. So let's start out by looking at the engineering values. Here's our slope map. And what we see is the darkest areas have the steepest slopes, grey areas have moderate slopes, and transparent areas have totally suitable slopes for building the road. So on top of this, we can overlay a surface drainage map. Okay, once again, the darkest areas have the worst surface drainage, grey areas, moderate surface drainage, and the transparent areas represent no constraint in any way, shape or form for building a road. Now, what we're seeing in the right here is this surface drainage map overlaid on top of the slope map. So we can see here surface drainage on top of slope. Now, what we're going to see is from now on, I'm going to go a little bit quicker, and we're going to see all these maps for engineering values in succession overlaid on top of each other to create a composite map of all engineering values. So what we can expect is that the darkest areas in the composite map will represent those areas that are least suitable for building the road in engineering terms, and the transparent areas will represent those areas that are most suitable for constructing the road in engineering terms. Okay, surface drainage on top of slope in this one. Bedrock foundation on top of surface drainage on top of slope to the right. Soil foundation on the left. We're still dealing with engineering values. We're going to overlay that on top of all these other maps. And we now have soil foundation on top of bedrock foundation, on top of surface drainage, on top of slope. And we can see that there's all these darker areas, there's grey areas, and there's some transparent areas as well. Okay, so the optimal route for the roadway in engineering terms is starting to show itself. Okay, soil drainage on top of on the left, now overlaid on the other maps on the right, and susceptibility to erosion on the left on top of all the other maps. So we've now got susceptibility to erosion, soil drainage, soil foundation, bedrock foundation, and surface drainage and slope all on top of each other to create this composite engineering map. And we can see that there's lighter areas, okay, a few areas where they're transparent, and some areas where they're certainly quite dark. Now let's look at social values. We start off with forest values. So the oldest forests with the greatest forestry values will be shaded the darkest, and those areas that are not forest at all will be transparent, and those areas that are, moderate quality forests will be shaded a grey, this more grey colour. So we're going to end up creating this map of composite map of social values. So we've got historic values. So things like old homesteads and things like that are shaded dark. We don't want roadway to go through those. And so we've now got historic values on top of forestry values on the right. Institutional values, hospitals and school grounds and cemeteries and things like that. They're areas of fairly high institutional value. We don't want a roadway going through those if possible. And we can see those in the right-hand side overlaid again. Land values, the highest land values, we don't want a roadway going through those because it's actually going to cost more to purchase the land. Once again, on the right, overlaid. Recreational values, on the right, overlaid. Residential values on the left, on the right, overlaid. We're getting closer to our composite map. Scenic values in 3 shades on the left, overlaid on the right. Tidal inundation. I'm not sure why this is a social value, but anyway, I think it probably should have been an engineering value. But it's overlaid on top on the right. Water values, well, arguably a social value. Water quality is a very important thing. Once again, overlaid on the right. Wildlife values on the left, overlaid onto all the others on the right. And here's our 2 composites in the end. So we've got our engineering values on the left, and we've got our social values on the right. Now the next thing will be to overlay these 2 maps on top of each other. And what Ian McHarg came up with was this map here, which he called the recommended minimum social cost alignment for the roadway. Now, a whole bunch of work pulling all those maps together for Ian McHarg and interpreting the 3 shades. But you know what? Overlaying them probably took not much time at all. And this is very, very typical of a GIS project. You can spend a lot of time on creating maps, particularly for specialist projects where the maps don't exist. And then you get to the map overlay technique. Any mug can do that. But it's the really important and time-consuming bit is pulling the databases together. The book we've been talking about is by Ian McHarg, and it's called Design with Nature. This book is still a prescribed text in many courses around the world, especially in landscape architecture, but also in the odd GIS course. Now, it is a foundation book. If you can understand this concept of map overlay, as I've said earlier, it is a very important thing to understand, and it will stand you in very, very good stead for having a good conceptual understanding of geographical information systems.